Hello and welcome to another exciting chemistry session. This is your host, Mr. Monse, chemistry tutor. So as of today, we're going to do a quick revision on atomic structure. So we'll run through just to give ourselves a recap on what basic principles I was supposed to know before we get into the actual task for the day. So what we're looking at is called a fate simulator. So you can get a fate simulator on Google. You can go to Google and search for a fate simulator, PHET, and then you will be able to interact with some of the chemistry activities that comes with the package. So what we're looking at here is the components we need to build an atom. So we're looking at atomic structure. How can we come up with the structure of an atom? So when you go to my series on atomic structure, if you start from the first recording, you will be able to understand what encompasses the structure of an atom. So what we have here at the center is the nucleus, and then the nucleus is surrounded by the shells, of course, all the energy levels. So for us to build an atom, we need protons, we need neutrons, and we need electrons. And then to understand the characteristics of the protons, neutrons, and electrons, we are required to know the location where we can find the protons, where we can find the neutrons, where we can find the electrons. So according to the knowledge or to the information on the atomic structure, we should know that protons and neutrons are located in the nucleus, and electrons are found orbiting around the shells or the energy levels. So for example, wants to build a hydrogen atom. How can we build hydrogen atom? So the first thing we have to do is we need to understand the nuclide of hydrogen. So hydrogen is H11. Then we can determine the number of protons, the number of electrons, the number of neutrons. Now, if we are dealing with an atom, there is always a principle that we should never forget. And the principle is that proton number is equal to electron number, provided we are dealing with an atom. Therefore, according to the nuclide, what is found at the bottom is called the proton number. So this will be 1. Then, according to this principle, the P is equal to the E, meaning this is 1. How do we find the neutron number? So for the neutron number, we get the relative atomic mass, which is 1, then minus the proton number, which is 1, then we get a 0. So if I'm going to construct an atom of hydrogen, I should know that in hydrogen, I have 1 proton that will sit, that is in the nucleus at the center. Then do I have a neutron? No, so the neutron will be 0. How many electrons? 1, and the electron will go in the first shell. So the system itself will recognize what I have built, and it will tell me that this is a neutral atom, because the proton number is equal to the electron number. And if I go on the periodic table, it is recognized there that this is an atom. If I was to check the charge of this particular speech that I have built, I will notice that the charge is at 0, because the P is equal to the electron. The positively charged particle neutralizes the negatively charged particle, and then the mass is 1. Let's try to look at a different atom. For example, we want to build lithium. How do we build lithium? So we'll go to the periodic table and understand the nuclide of lithium. So lithium is Li, then there's 7, and there's 3, meaning my proton number is 3, my electron number automatically becomes 3, and my neutron number is 7 minus 3, which is a 4. So if I'm going to build lithium, I understand that I should have 3 protons at the center. Then how many neutrons? 4 neutrons. 4 neutrons. How many are there? 3. 4 neutrons. And then electrons, I'll have 2 electrons in the first shell and the other one in the third shell, because the first shell is full by 2 electrons. So from there, I will be able to check even from the periodic table that what I have built is lithium atom. In terms of charge, it's a neutral atom because the P is always equal to the E. And in terms of mass, this has got a mass of 7. This is a quick recap on the atomic structure. Now, we have what we call ions. Ions are categorized into cations and anions. If you want to learn more about this, you can still go back to my atomic structure lessons and you still find the information there. So we have ions, which are called anions and cations. A cation is a positively charged. Then an anion is a negatively charged particle. So for you to become a cation, you have to lose electrons. For you to become an anion, you have to gain electrons. So losing is from the metals, and gaining is from the non-metals. So for example, we want to look at lithium ion. Lithium ion meaning lithium is coming from a metal side, and according to the rule of losing electrons or giving away electrons, it is clearly stated that metals will lose electrons according to their valency number. So the first thing you have to do is know the valency number of all these groups on the periodic table. Group 3, group 4, and so on and so forth. So all the elements in group 1 will lose 1, all the elements in group 2 will lose 2. So therefore, if I want to have a lithium ion, meaning the lithium will just lose this electron in the last shell, and then I will remain with 2 electrons to satisfy what we call the duplet rule. And in the actual drawings, we usually put the square brackets or parenthesis brackets, and then we indicate how many was lost. And the opposite happens in the anion. In the anion, you have to gain electrons. For example, we are looking at oxide ion. Oxide ion, let me try to construct. So oxide ion, we're looking at oxygen. Oxygen becoming an ion. So just to give you a quick recap on the anion of oxygen. So oxygen is 16(8). So if oxygen is an atom, the proton number is always equal to the electron number because this is an atom. So this should be 8, this should be 8, and the neutron number will be 16 minus 8, which will be 8. But when this becomes an ion, it's called oxide ion. You can still go back to my channel and you'll get all the information about this. The proton number in an ion, the proton number in an ion is never equal to the electron number because there is losing and there is gaining. So initially this will remain 8, but this will gain according to the valency number. So this becomes 10 and this still remains the same. So what changes in an ion and an atom is just the electron number. So if we're going to build this, we'll look at the configuration. So we should have 8 neutrons, sorry, at the center. So that is 4, 5, 6, 7, 8. And then we should have 8 protons. 8 protons 8 protons. How many are they? 6, 7, 8. And then the number of electrons, 2. Remember in the first shell, it's 2. Then if it was an atom, it was supposed to have 8, meaning 2,6. 2,6. If this was an atom, it's supposed to be 2,6. Sorry, 2,6. And here it tells you this is a neutron atom. But if it has gained 2, it has to become an ion, meaning there will be extra 2 electrons. So this satisfies what we call the octet rule. So they undergo all these processes in order for them to become stable. So in our normal drawings, we do this. We show the brackets and then we'll say 2 negative to indicate that it has gained 2 electrons from somewhere. So this is just a quick recap that I want us to do with you before we jump into the task for the day. So the task for the day is a very simple exercise. We're going to play a game and we'll answer quite a number of questions on this particular topic. And there we go. So the first question is find the element. Find the element. How do we find the element? Remember, this color from where we are coming from, it's representing protons. Let me just take you back. So this color is representing protons, master the color. Gray is representing neutrons, and blue is representing electrons. So when we go to the game, we say, when you have 1 proton, what do you have? So when you have 1 proton, what you have is hydrogen. And the question is this hydrogen a neutral atom or is this hydrogen an ion? You can take a guess. So this hydrogen is an ion. Why? Because the proton number is not equal to the electron number. This means that initially this guy had an electron which it has lost. Therefore, this is an ion. So we'll click on the ion and we check. And the answer is correct. We'll go to the next question. Find the element. So the element is always determined by the proton number. If you want to know the location of an element on the periodic table, you locate an element using the proton number. So I will find number 10. So which one is number 10? So you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the 10th one is neon. And the question is neon an atom or an ion? What guides you is if the proton number is equal to the electron number, then what you're dealing with is a neutral atom. And that is correct. We go to the next question. Find the element. So now this is yours. What element are we dealing with? Looking at what is given. So the first thing you have to do is identify the number of protons. How many protons do we have? So we have 2 protons, correct. So we'll go for the one with 2. 2 is helium. Then is this a neutral atom or is it an ion? What are you supposed to do? Exactly. So you compare the proton number and the electron number. If they are the same, then what you're dealing with is a neutral atom. Correct. Let's go for the 4th one. Again, find the element. So remember, for you to identify the element, the first thing you have to look for is the proton number. So what is the proton number in this case? My proton number is 8. Correct. So which one is 8 when you go to the periodic table? 8 is oxygen. Then the question is this oxygen an atom or an ion? So remember, you compare the proton number and the electron number. This is indicating that the oxygen gained. Therefore, it's an ion. Correct. Let's go for the last question. from the first challenge. Find the element. So to find the element, the first thing you have to do is, yeah, correct. You look for the proton number. How many proton numbers do we have? Exactly, we have 2. So 2 meaning helium. Is this an atom or an ion? Excellent. So this is an atom, and the reason is that because the proton number is equal to the electron number. All right, let's confirm. And this is correct. And that is our 10 out of 10 for the first challenge. Let's go for the second one. In the next challenge, what do we have? All right, the question is, what is the mass number? How do we get the mass number according to the information from the atomic structure? Excellent. So for you to get the mass number, you just add the P and the N. The proton number and the neutron number gives us the mass number. All right, so let's try this. So we are saying 9 plus 10, giving us 19. Let's check for 19. Is it correct? Excellent. Let's go to the next question. What is the total charge? Okay, we're not going to use this formula. What is the total charge? So to get the total charge, you have to understand that if the P is equal to the E, then the charge of an atom is always 0. So is this P equal to the E? Yes. Therefore, my charge is 0. An atom has got a neutral charge. So let's check if this is correct. Yes. Let's go to the next question. We're looking at what is the total charge. So whenever you're dealing with a charge, like we said in the previous question, the first thing we have to look for is this equal to this? If it's not, it means that here there was a gaining of 2. What is gaining in chemistry? Gaining in chemistry is signified by a negative sign. So what do we do? Meaning there was a gaining of 2 electrons for us to move from 8 to 10. Let me check. This is correct. Let's go to the next question. All right, so the next question requires us to find the mass number. How do you find the mass number? Remember, mass number is P given by N. We have the P. Do we have the N? There is no gray particle here. So meaning we only have 1 proton. So the mass number is 1. And that is correct. Excellent. We have another question. How do we figure this one out? What is the mass number again? So to get the mass number, remember it's proton exactly added to neutron. So 7 plus 8. Exactly 15. So this gives us 15. So let's confirm the mass of this particular atom, 15. And that is super correct. That is 10 out of 10. Let's move on to look at the next challenge. As we move, the challenge is getting a little bit tough, so we have to make sure that we also step up and yeah, beef up our knowledge on this particular topic. Okay, so the question is here, what is the charge? Remember, when you're dealing with a charge, compare the P and the E. Is the P equal to the E? No. Was there gaining? Was there losing? So there are, yes, there was losing. What is the meaning of losing? Initially, there should be an electron here. So losing in chemistry is positive, correct. Gaining is negative. So what do we do? Excellent. So we say positive one, meaning this hydrogen lost, or this hydrogen gave away an electron. That is why we cannot see a blue electron in the shell. And this is super correct. Let's go for the other question. Yeah. Okay, so this question is asking us to find what is found there on the nuclide. When you go to the periodic table, you have A, you have B. So the A is known as the relative atomic mass, or the mass number, or the nuclear number. So how do we get this? This is given by P plus N. So you get the two, you add them. 16 plus 18. Let's do the ordinary math. 6 plus 4, 14. 1, 1 plus 1, 2 plus 1, 3. So we're talking about 34 as a mass. Let's see and confirm if this is correct. This is 34. Is it correct? Excellent. Let's go for the next question. I think we have put in that one correct. This is the next question. All right, this is the next question. So the next question requires us to all right, requires us to, all right, what is the charge? What is the charge? So if you're talking about the charge, look at electrons and protons. What happened here? Was there a loss or there was a gain? So there was a gain of 2. What is a gain in chemistry? It's a negative. Correct. So what do we do now? So we say there was a gain of 2 electrons. And that is super correct. Let's go for the last. No, this is one, but okay. Okay, let's clear this. What is the question? The question here is, tell us the proton number. Come on, the proton number is always there, meaning it's 1. There's only one proton particle. Let's confirm. This is correct. And we go for the last question in this section. Okay, where are we? It's clear. This one requires us to find the mass number. How do you find the mass number? Mass number is proton plus neutron, correct? So this is 2 when you add those 2 particles. Confirm, and that is correct. Let's go for the final and ultimate challenge. We see what we can get from this one. All right, so this one will be a little bit of a challenge as it is the last one. So what are we required to do here? So they've given us this nuclide, hydrogen with a mass of 2 and the proton number of 1, and they want us to build this atom. So how many protons do we have? We have 1 proton. How many neutrons? How do we get the neutron number? So 2, we subtract 1, meaning we have 1 neutron number. How many electrons? So since it's a neutral atom, the proton number should be equal to the electron number. Therefore, it means that we have 1 electron right there, and the charge is 0. So if we check, it's correct. Let's go for the next question. So looking at the structure given, they want us to find the charge, they want us to find the mass, they want us to find the proton number. So the proton number is clear, we have 1 particle, so we say 1. What about the mass? How do you get the mass number? Excellent, so the mass number is given by proton and neutron. But do we have the neutron here? No. Therefore, we only have 1 proton. So that will be 1 plus 0, which is 1. What about the charge? Remember, if P is not equal to E, it means that there is a loss or there is a gain. Have we lost an electron here? Have we gained an electron? Excellent, so there was a loss. What is a loss in chemistry? It's a positive. So it's a positive one. And that is super correct. Again, we are required to build a nuclide. How many protons? 16. So we know where to find the proton number. So proton number 16. How do we get the mass number? Exactly. So you add this to this, and this will give me 35. 16 plus 19 will give me 35. Excellent. Is this a neutral atom? No, because the proton number is different from the electron number. Was there a gain or was there a loss? Excellent. So that was a gain. There was a gain of electrons. What is a gain in chemistry? It's a negative. Excellent. Let's go for this one. We have the nuclide and they want us to build how many protons. What we find at the bottom is known as proton number. So we have 12. How do we get the neutron number? So neutron number always we get the mass number, the number on top, we subtract the proton number. So this gives us a 4, this gives us a 1. So meaning we are talking about 14. 14. What about the electrons? Correct. So the electron number is determined by the charge. If the charge is neutral, it means that your P is equal to the E. Therefore, the electron number is as well as excellent, as well as 12. We confirm, and that is correct. Let's go for the last one and finish up this particular exercise. Okay, so for this one, allow me to clear so that you can see. Yeah, they want us to build this particular atom. So what do we do? How many protons? 9. Exactly. How many neutrons? So 19 minus 9. That'll be 10. How many electrons? 9. Excellent, because the charge is 0, meaning the P is equal to the E. Let's confirm. And that is excellent. So that brings us to the end of the revision on atomic structure. For more questions or revision, you can visit my YouTube channel and you'll find a series on atomic structure, and you will be able to answer all the questions. If you want to have an interaction of this particular game, you can visit the fate.com, and you will be able to find a number of activities all lined up for you. So if there are any questions, if there are any topics that you want us to tackle, feel free to mention those topics in the comment section, and we'll be delighted to attend to you. It has been your host, Mr. Musa, chemistry tutor. Until next time.